Haas today. All right. So we got to talk. We're going to add one more step on your supplemental sheet, but keep that out. We'll add it later on. Okay, we won't add it right away. We've got to figure out what a ha is first before we get into it.
Still trying to get mine out.
Come on, man.
That's right, man.
All right. So Monday we learned all about vertical asymptotes. Okay? Right? So those were dashed lines on our graph, but they're really important because they're lines that we can't cross. Okay? Right? Today we're going to learn about horizontal asymptotes. Okay? And now a horizontal asymptote is important because it gets tied in with your end behavior. So if you know how to find the horizontal asymptote, you don't have to do that logic or as much logic to figure out what the end behavior is. Because the horizontal asymptote is what the function I'll just say what f of x. We'll shorten it up. We'll just say what f of x, or the function, approaches at x equals infinity and x equals negative. So the left and the right sides of your graph is what your function is going to approach when we get out there. It, the horizontal asymptote, is a line, just like it was for the vertical one. Okay. So it's going to have a specific form. Okay. Since it's a horizontal line, what is the form going to be? Y equals some number. Let's see. Okay. So it's always going to be y equals some number. Vertical, x equals some number. Horizontal, y equals. Okay. It is going to be a dashed line on your graph. We'll get to graphing tomorrow, but it will be dashed. It's got to be on your graph. Kind of just like vertical asymptotes. And so far, everything is basically the same, except as far as x instead of y, or y instead of x. The difference is, yesterday and the day before, we could have multiple vertical asymptotes. And a couple of the videos, a couple of the examples on the video you watched yesterday had more than one vertical asymptote. The difference here is we can only have one or none. So there are only two choices for horizontal asymptotes. You either have one or you're not going to have any at all. So let's go into, rather than try and discover what the rules and all that such are, we're gonna dive into it. I'm just gonna tell you what's going on with them. Okay? So we have to compare the degrees of the numerator and the degree of the denominator in order to find the horizontal asymptote. Let's take a step back. What is the degree of a polynomial or a function? We got the biggest exponent. Yep. biggest exponent. So you're looking at the biggest exponent on the top. You're looking at the biggest exponent on the bottom. That's it. You're just going to compare the two. Okay? So if you're comparing two numbers, you've got three choices. Either the first one's going to be bigger, the second one's going to be bigger, or they're going to be the same. Okay? One of them is going to be bigger, or they're going to be the same. Okay? So if the top degree, and only degree now, if the top degree is bigger than the bottom degree, then there's no horizontal exponent, or excuse me, no horizontal asymptote. Okay? So for instance, what the function would look like here would be like x squared plus 4 over 2x minus 5. Okay? So this has a degree of 2 on the top, a degree of 1 on the bottom, because even though it's not written there, we're assuming that that exponent is 1. So then that would be a big over small case. And so therefore we would have none for our s. Okay? So we would say here our horizontal asymptote is none. Okay? That's first scenario. Second scenario, bottom is bigger than the top. Okay? In that case, we have our function. It would look like, let's say, x over 3x cubed minus 7. Degree on the top is 1. Degree on the bottom is 3. Small over a big case. If that's the case, then y equals 0 is our horizontal asymptote, which is just the x-axis. You had a lot of those yesterday. That's going to be your most common one. Your most common horizontal asymptote is going to be this case number 2, the x-axis. Okay. Good so far? All right. Well, I was going to scroll down. Is it okay? I might even, go like this, jump it up there, but they'll still be there. We'll still make it be there for you. Okay? Last one is if they're the same. Okay? Now I'm going to go abstract with you on this one. I'm not going to give you a specific example. So if they're the same, so in this case it would be whatever n is, we call those the same. Then what we're going to do is we're going to have a horizontal asymptote, but it's going to be the line y equals a divided by b. And we get those two numbers right here. They are the lead coefficients of the top and the bottom. So if the degrees are the same, the horizontal asymptote is the lead coefficient, top over bottom. And we'll have some examples of that. Okay? Questions on that? You guys a minute to get caught up. All right, so now let's go to our supplemental sheets. Okay? Let's add in this new information onto that. Okay? And then again, you want to have that sheet out ready to go for you. Okay? Right? So what I would do, you either add this part, you can either add it at the top, or you can add it, but you got to kind of have it in step number 2. So you can either add it there, or I've got it written again down there for you. So don't freak out if you don't have it written down right now. Okay? So Monday, we talked about we're going to skip some space for step 0. Okay? We're still going to skip that space for step 0, okay, because we're still not there yet. Okay? Then on Monday, we said step number 1 is find the domain and any vertical asymptotes. Okay? One thing that I'm going to add to step number 1 here is I'm going to remember the form of giving the domain is that. So write that right on there. And then we have it, everybody's got it written down. Okay? The capital D, colon, all real numbers with the funky R, comma, X doesn't equal, and then you got to fill in the whatevers. Okay? So then we come to step number 2. Okay? Oh man, it didn't save. Biscuits and gravy. Well, while you guys are writing this down, I'm going to go back in here and I'm going to change this because I wanted this to say delete. I wanted this one to say delete, colon, oh, and this has got to move too. Bless you. That would be vintage, yes. Yes. All right. So, what I want to do for these 2 examples is I want to find the domain of the function and identify any horizontal and vertical asymptotes. Okay? Okay? So I'm just going to scroll down. So that's what we're going to find. Okay? So we're going to look like this. Okay? All right. So we need to find the domain first, any vertical asymptote, and any horizontal. Give you a second to just write them down, and then we'll get her going. So, according to our wonderful supplemental sheet, the cheat sheet, first thing we got to do is find the domain. How do I find the domain? Denominator, bottom, whatever you want to call it, set that equal to 0. So in this particular case, that would be x plus 1 equals 0. Then I got to solve that, right? Subtract 1 from both sides, gives me x equals -1. Love it. Okay? So my domain then is capital D, colon, all real numbers, x cannot equal -1. Yes? Love it. My vertical asymptote would then be x equals -1. My restriction, my exemption, whatever you want to call Okay? Love it. Now, horizontal asymptote. What is the degree of the top? 2. What is the degree of the bottom? 1. There's a 1 there. So that's 2 over 1, which is big on top, small on the bottom, which, according to our notes, says none. There is none. So we actually write the word none. Practice. Here's the practice. It's cleaner. Okay? All right. Go to number 2 now. Okay. First thing I got to do is find the domain. So I do what, Bugsy? Everybody, how I want to do it. Factor. Can we factor it? What does it factor to? X plus 3x minus 3. Then yes. Okay. Like it. So what's my domain? Can I write it like that?
Yeah.
Oh, yeah.
Yes.
So that one.
For this one I can. Yep. But the next one, no, because they're 2 separate lines. Okay? So because they're 2 separate lines, in the next line, x equals 3 and x equals negative. Okay? Degree of the top, 2. Degree of the bottom, 2. So they're the same. So that means then that I have to look at, what's the lead coefficient on the top? 6. What's the lead coefficient on the bottom? 1. Okay, so let's assume that there's a 1 there. So I've got to look at those 2 numbers. So my horizontal asymptote would be y equals 6 divided by 1, which is just y equals 6. Okay. Questions, comments, concerns, clarification. Now, I'm going to show you how we can do the same things that we were doing Monday and Tuesday, but now we can do them much faster. Because now we know what the function is approaching as we get out to the left and the right sides of our graph. Okay? So things are going to go a lot easier now for us. Okay? So we want to find the domain of the function, identify horizontal and vertical asymptotes, then find end behavior and asymptote behavior. So what I'm going to have you guys do is I'm going to have you find me those 3 right now. Then together we'll do end and asymptote behavior. Okay? Go for it. Okay. What do we do first? Set the denominator equal to 0, right? So that's going to be the quantity x minus 2 cubed equals 0. Yes? Now, we've got 2 options. I could write that all out as x minus 2 times x minus 2 times x minus 2 equals 0, right? and then set all of those equal to 0, which really I don't have to do one of them, right? And so then I would have x minus 2 equals 0, so x would equal 2, right? Okay. Other option is I can take the cube root of both sides. And that puts me right into that. Okay. All right. So 2 is my restriction. Just a smooch. Just a smooch. Okay. So that would tell me then that my domain is all real numbers, but x cannot be 2. Which means my vertical asymptote is x equals. Okay. Horizontal asymptote. What is the degree on the top? 1. What is the degree on the bottom? 3. Right? So what do we got? Y equals 0. Not just 0.
Y equals 0.
Y equals 0. 0 is a number. Y equals 0 is a line. With me?
Yeah.
Now, what we're doing with just those pieces of information is we have just determined our graph. You're right now, your graph is up here in between your ears. Okay? It's not on paper yet until tomorrow. Okay? Okay? Tomorrow we're going to start graphing. So, let's take that now and let's think about this. So we've got a vertical asymptote at x equals 2. We've got a horizontal asymptote at y equals 0. Right? Okay. We need asymptote behavior and we need end behavior. You pick which one we want to do first. Asymptote behavior? Okay. So I know that at the asymptote, the function has either got to make a turn and go up or a turn and go down. Right? Okay. I just need to be close to that asymptote. Right? So pick me a number that's close to 2 on the right side. 2.1. Love it. Okay? Now, what I'm going to do is I'm going to take 2.1 and I'm going to put it into my function. But I'm not going to figure it out because I know it's going to infinity. I just need to know if it's going up or if it's going down. Okay? So if I put 2.1 into my top, I've got a positive number times a positive number. That's a positive number. So my numerator is going to be positive. If I put 2.1 in the bottom, I've got 2.1 minus 2. Is that positive or is that negative? Positive. If I cube a positive number, if I cube any positive number, is it going to be positive or is it going to be negative? Still going to be positive, right? So my denominator is still positive. Right? Positive divided by a positive? Positive. So this one is going to go to positive infinity. With me? Need to see it another time. Well, we'll see it on the other side, right?
Yeah.
Okay. So what's a number really close to 2, but on the left side of it? 1.9. Put it in the top. Positive or negative?
Positive.
Positive. Positive 4 and positive 1.9 is positive. Put it in the bottom. Negative. 1.9 minus 2 is negative 0.1. Right? A negative number cubed, negative times a negative is a positive, times a negative is a negative. So my denominator there is negative. Positive number divided by a negative number. It's going to be a negative number. So this one goes to negative. Now, that written out, because now we got to write that stuff out, right? Okay. So that written out would be F breaks. What's going on? Yep. As x approaches 2 from the right, my function goes to positive infinity. As x approaches 2 from the left, my function goes to negative. Yes? Okay. So that was my asymptote behavior. Now we've got our end behavior. Because we know that it's going to 0, we can say as x approaches positive infinity, my function is going to 0. As x approaches negative infinity, my function is going to 0. I know that already. We just now got to figure out if it's approaching 0 from above or from below. Okay? But we know, because we know what our horizontal asymptote is now, we know that that's what it's approaching. Okay? So let's go back up here. Let's scroll back up here so we can see our function. There we go. I'll switch over here to green now. Okay? I'm going to do positive infinity first or negative infinity first? Positive infinity. Okay? So that's way over here. X equals positive infinity. The positive huge number, right? I know it's going to 0. So I just got to figure out if we're going from above or from below. Right? Okay? So, put an infinity, positive infinity in the top. Positive or negative? Positive. Put positive infinity in the bottom. Still positive, right? Because we got a positive number, and we multiply it by a positive number, and multiply it by a positive number. Still positive. Positive divided by a positive? Positive. So this one's going to 0 from above. Bugsy, wake up. So well, so far. And then you decide to fall asleep. You're right. It was an unconscious decision. Okay? Let's go negative now. Negative infinity. Put negative infinity in the top. Negative, right? Because it's a positive times a negative, so that's negative. Put negative infinity in the bottom. Be negative, right? Negative number minus a number is still going to be negative. Cubed is still going to be negative, right? Negative divided by a negative. Positive, right? So that's going to go to 0 from above still. Okay. Now, supplemental note here. Here's how I know that you just figured out what your graph is. Right? So here's your graph. Right, there's your graph. Now notice what happened. We can't cross over a vertical asymptote, but we can cross over a horizontal asymptote. Questions, comments, concerns, clarifications from today? So as of this moment right now, you should be able to do numbers 1, 2, and 3 from your yellow worksheet. I strongly encourage you to now take this logic that we just did and go back to numbers 1 and 2 and make sure that you did those right with your end behaviors and your asymptote behaviors. Okay?